Welcome back. In this video, we are going to solve a structural design problem that involves an isolated footing design using load and resistance factor design method based on eStructural Design Tao found on the App Store. Design an isolated rectangular footing using load and resistance factor design for a 10 inches by 10 inches square column carrying an actual dead load of 30 kips and actual live load of 15 kips. Design criteria as follows: strength of concrete 3000 psi, main bars 5/8-inch diameter grade 40, soil bearing capacity 2500 psf, approximate dimension ratio of 1:2. The footing carries an actual dead load of 30 kips and actual live load of 15 kips for a factored load of 60 kips. Enumerate input parameters required. Footing name F3, shape of footing, rectangle, depth of footing, 10 inches, depth from natural grade line, 4 feet, long direction bars, 5/8-inch diameter at grade 40, short direction bars, 5/8-inch diameter at grade 40, strength of concrete, 3000 psi, soil bearing capacity, 2500 psf, column, 10 inches by 10 inches square, and total load, 60 kips. Given allowable soil pressure equals 2500 psf, assume footing depth equals 10 inches, and depth from natural grade line equals 4 feet, the effective soil pressure is 2058.33 psf. Given actual dead load of 30 kips and actual live load of 15 kips, the assumed footing width is 40 inches and footing length is 79 inches. The ultimate soil pressure is 2734.18 psf. Critical section diagrams for punching shear, beam shears, and moment evaluations. At long direction, given ultimate soil pressure equals 2734.18 psf, footing width equals 40 inches, footing length equals 79 inches, and column side equals 10 inches. The maximum moment is 451,994.13 inch-pounds. Given resistance factor equals 0.9, B equals 40 inches, and D equals 7 inches, the beam design ratio Rn equals 256.23 psi, and reinforcement ratio Rho equals 0.00676. Continue at long direction. Given Rho equals 0.00676, B equals 40 inches, and D equals 7 inches, the area of steel for long direction bars is 1.8928 square inches, and the number of bars for 5/8-inch diameter is 7. At short direction, given ultimate soil pressure equals 2734.18 psf, footing width equals 40 inches, footing length equals 79 inches, and column side equals 10 inches, the maximum moment is 168,750.17 inch-pounds. Given resistance factor equals 0.9, L equals 79 inches, and D equals 7 inches, the beam design ratio Rn equals 48.44 psi, and reinforcement ratio Rho equals 0.00122. Use Rho minimum of 0.005. Continue at short direction. Given Rho equals 0.005, L equals 79 inches, and D equals 7 inches, the area of steel for short direction bars is 2.765 square inches. The area of steel at center strip is 1.85882 square inches, and the number of bars for 5/8-inch diameter is 6. The area of steel at outer strip is 0.45309 square inch, and the number of bars for 5/8-inch diameter is 2 on each side. The maximum beam shear force at long direction is 20,886.1 pounds. The nominal force is 27,848.13 pounds, less than 30,672.46 pounds. The maximum beam shear force at short direction is 12,000 pounds. The nominal force is 16,000 pounds, less than 60,578.11 pounds. The maximum punching shear force is 54,512.71 pounds. The nominal force is 72,683.61 pounds, less than 104,286.37 pounds. Design recommendation as follows. Fc prime equals 3000 psi, Fy equals 40,000 psi, Qa equals 2500 psf. Footing size is 3 feet 4 inches by 6 feet 7 inches by 10 inches. Depth of footing from natural grade line 4 feet minimum. Long direction bars of grade 40, 7 pieces 5/8 inch diameter bar at 5 and 3/4 inches on center. Short direction bars of grade 40, center strip bars 40 inches wide, 6 pieces 5/8 inch diameter at 8 inches on center. Outer strip bars 19.5 inches wide each side, 2 pieces 5/8 inch diameter bar at 8 and 1/4 inches on center each side. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.